So welcome all. My name is Agustin. I work at the support team in Percona, and I am going to be talking about how to extend PMM with, among others, custom collectors. So we are going to go through a brief overview of what PMM is and what data it has already, just so we are all on the same page. Maybe if we don't need it, we can skip it real quick. I will ask now. And then we are going to check the three main and unofficially supported way of extending PMM, which are the custom query collector, text file collector, and external exporters. And then I will show you one integration, which I think is really cool and can really add a lot of value, which is using Loki. And then just tips on troubleshooting and how to get the dashboards and graph we need. So, who is already familiar with PMM? I'm guessing if you're here, it's because you're using it, so we can skip this. As you already know, this is mainly Grafana and the Prometheus compatible Victoria metrics underneath, and then ClickHouse for query analytics. Right, so it provides support for Postgres, MySQL, and MongoDB, and all of its forks, of course, and our Percona server and distribution for all of them. And it supports both on-premise and cloud deployment. So you can, as we are going to see now in the architecture, you can have actually the PMM client. This is a client-server architecture. You can have the PMM client running on the database server itself, or it can be pulling data remotely for instance, RDS or GCP. So you don't necessarily need a PMM client running, but this will get you the OS metrics. So it's highly, I suggest you, if you can, that you do it. So the first thing I would recommend, of course, is to see if PMM already provides the data you want, right? PMM has a lot of information already. So my first suggestion is for you to get familiar with the interface and how to navigate PMM to fully get all the information out of it, right? So let me go back. The three main levels of depth, let's say, that we have in PMM are metrics, which are the most atomic value, let's say, and then we have graphs, which are metrics put together in a nice way, and then we have dashboards, which are graphs put together in a nice and cohesive way, right? So navigate through the dashboards, again, just check what PMM can offer, because it may already have what you need, right? So as mentioned, we have three main ways to extend what we get from PMM, and those are custom queries, which are going to be defined in YAML files, text file collectors, which will simply scrape text files that we create adhering to the to Prometheus definitions, and then external exporters that just run separately, and that would be like analogous to what we already have, the MySQL, the MySQL exporter, the Postgres exporter, etc. So all of them provide the three main resolutions for the metrics, which are low, medium, and high resolutions. And then the PMM client itself will add some metadata on this in the form of labels, right? Like node name, node ID, etc. So let's begin with the first way of extending, which is with the custom queries, right? So this is going to get the exact query you want to run from the YAML file, and it will also get data on which kind of information is being returned in each of the columns from that query, right? We are going to see one definition now, but it's a very simple YAML file. You just, the most complicated is to actually get the data you need from the query, right? So it uses the already established PMM client connection to the database, so that is fully resolved by PMM, and we don't need to think about it, as we are going to see in the text file collector, this is a great advantage of the custom query collector, because the text file collector doesn't have any information on the database connection. And for now, it supports only MySQL and Postgres. So if you are using Mongo, you are going to have to use the text file collector. And then I'm leaving there the link of a blog post on how to use them. So as I mentioned, the collectors support the 3 resolutions and support MySQL and Postgres, and this is the directory tree for the main 2 directories in which we need to add the YAML files we want with our custom collectors. So that's going to be user local Percona PMM2 collectors, custom queries, and then in there you will have MySQL and Postgres, both of them with the 3 resolutions, right? So having into consideration that the low resolution by default is 5 seconds, which means that your custom query will be running every 5 seconds. So 2 points to note. The query has to run faster than the 5 seconds, and you should also consider the potential load that it will have on the server, because it will be running a lot of times, right? Then the medium resolution, I think it's 10 seconds, and then low 30, or medium 30 and low 60. We can check after. But yeah, if your query is heavy, or if you don't really need that amount of information, just use the low resolution. So this is an example of the YAML file I was referring to, right? So the first line here is the namespace, which is going to be the first part of the metric name, right? So the namespace is going to be prepended to all of the metrics that we collect, right? And then we have the query. In this case, it's of course this is you can think of it as a template. So it's just select column 1, column 2 from schema table where condition. Okay. Now this query will return 2 columns, and then we need to tell PMM metadata on these columns, right? In this case, I'm under the metrics section. We will have the same name as you are using here. You can use as here if you want, right? So column 1 as whatever, and then use the as here. And then usage is going to be label if it's a string, and then you can have either gauge or counter depending on what the metric does, right? So this is going to be on each case. So this is an example for PostgreSQL. We don't have so far any information on replication. So this is something we did when we had a customer asking how we could implement this in PMM and do it fast, let's say, right? Without having to go to the development team and wait for the next release. So this is what we did. This is a query we were already using for our own troubleshooting when a customer comes with questions on our replication setup. So this will get you the where is it? The byte lag. Well, anyways, this will get you the replication lag that the replicas have in bytes, right? And it will also tell you the application name, which in our case in particular we are not going to use, and the client address, which we are going to use, and then the state and the byte lag, right? So how can we use this information? This, as you can see, is exactly the same as we saw in the example, and all of the queries are going to start with PG replication, and then we will have 4 of them, right? So it's going to be PG replication application name, PG replication client address, etc. Right? So is it unlimited? Is it the output of that query stores in somewhere to get the extracted data? Yeah, it will be in Victoria metrics itself stored as a metric. So as you can see here, you have historic data on it, right? So as long as you have the file in user local Percona, whatever custom queries, PostgreSQL high resolution YAML, as long as that file exists, PMM will scrape that directory and will say, okay, I have a YAML here. Let me scrape this and add it to Victoria Metrics. And once the PMM client sends it to the server, that will stay in the server for the amount of data retention you have. So by default, it's 30 days. You can do more or less, whatever you want, but you will have at least 30 days if that's continuously collected. And then another layer of complexity here is that we need to be familiar with ProcFS language, right? You can check the dashboards that we already provide for some tips on what functions to use or how we are building the ProcFS, but it's not very hard. I mean, the learning curve is not so steep, right? So on the most basic example, I think, would be this, right? So you are going to take the metric and you are going to apply the irate function. This is a metric as we saw before. It's PG replica, which was the namespace, and then the name of the metric itself defined here. In this case, clearly this example is not matching the one here because this is lag byte lag. So it seems I took the screenshot before updating it, right? So we have the namespace and then the metric name, and then we can use templated variables so that we have nice filtering functionality in the dashboard. So we can select, for instance, one server in particular, right? So in this case, the service name would be the Postgres instance that we want to check the replication for, right? And then the interval, it will also be taken from the templated variables. And then you can add the other metric that we were exporting, the client address, which is added as a label, to that metric, and then this will appear in the legend itself. So we know each. In this case, we only have one, so it's not interesting. But if we had two replicas, for instance, we could know which of the lines would be, for instance, one line green and the other one yellow, and you have the legend there to know which replica is the one that is having those high values. So yeah, this is, as you can see, very easy to do after you are familiar with how you have to do it. It involves many steps, but it's really not that hard, and PMM already solves all the main issues for us, right? So we only need to have the query, basically, and that's it. If in doubt, you can use this same kind of ProcFS. It's a very good first approach to graphing values, and then again check the other dashboards. So this is the graph that we had, and we added this to the already available PostgreSQL summary dashboards. In the latest version, we are not able to edit the dashboards that we provide, so we will have to create a new dashboard for this, right? But we are going to talk about it at the end, but I would suggest you to just duplicate one of the dashboards we provide, remove the graphs you don't need, and start working from there. So yeah, that was the query collector. Now let's go to the text file collector, which is more basic in what it does, and it's a bit more complex to use. We have less aid from the PMM client, but this is just how it was conceived, right? So the text collector, what it does is, as opposed to having in the YAML file in which we define how we want to get the data, the text file collector is a dummy collector that will simply open the file that we add to a directory that we are going to see now. It will just open the file, get the metrics from it, and then send those to PMM server directly, right? So it has no idea how the metrics were collected. It has no idea if they are fresh or if they are old or if that file was made 30 days ago, and it will continue to scrape it without noticing, right? So it's a bit more complex to use because we need to guarantee that not only the file is created conforming to the, and I have it here. Where is it? I don't have the link. I don't have the link here, but in this documentation link, you will get how to conform to the Prometheus exposition format, right? We're going to discuss it shortly. It's very, very basic, but if we are not doing this correctly, the file will not be able to be scraped because there are going to be errors and the metrics won't be uploaded to PMM server, right? So that's another barrier to using the text file collector, let's say. So the last point here is that, again, PMM will just check the file. So what we need to do is use cron or an infinite loop with sleep to generate the files, right? So we are in charge of generating and maintaining the files with the metrics, right? PMM will not do that for us. Yep.
If we're using a cron job to generate that file, we're overriding each time, or
Overriding. Yeah. That's a very good question, actually. I'm not sure if you heard, but yes, you have to override the file each time, not append to it. And actually, you could have, if it happened. I'm going to show an example. It happened to me that if the generation of the file takes a lot of time, PMM will just read it partially, right? So what I did was just you create a temporary file and then move it, right? So the temporary file has to be created on another directory, of course, but so this is the analogous to what we saw in the custom query collectors. This is where PMM will try to look for these files, right? And it will scrape all of these for every 5 seconds for the high resolution. Every 5 seconds, it will open all the files, check them, and upload the metrics, right? And this is what I was saying. So if we don't update that file, it will continue to read the same file forever and ever and ever. And then to your question is, if we are generating these files, these temporary files in here, they will be read, of course, right? So just use the TMP directory and then move them, and that's like an atomic operation. So yeah, as you can see here, I was using the low resolution for writing a PostgreSQL wall.prom file, which we are going to discuss shortly, and it's not connected to the replication lag. It's another example. But yeah, all the files that you have here will be opened by PMM, and the metrics will be sent to the server. So the anatomy of a text file collector file is this. This would be the most basic example on the Prometheus rules that we need to adhere to. So basically, it's of course the hash there is a comment, and then you have there are 4 main ways of having metrics. The first one is the most simple, which is just the metric name and the value, no metadata, no timestamp, no nothing. Then the second form is metric name, value, and then timestamp. And as you can see here, value can be an integer or it can be a float. And then the third one is name, optionally one label, and then optionally one or many labels, and then the value. And then the fourth one is the same but with the timestamp, right? So this is what you would typically not this one, sorry. This is what you would typically be using because the timestamp is something that is going to be handled by PMM itself. So in this case, what did we want to achieve with this example? If you're familiar with the MySQL dashboards, we have a very nice one that has redo log usage. So that can help you assess how big your redo logs should be. In Postgres, we don't have this yet. So we ended up coming with, and we can't easily use the custom query collector because this has to have a notion of history, right? So we will need to get the initial wall LSN, and this is against which we are going to compute the other deltas, right? And the custom query collector doesn't have any history, or it doesn't know about any past instances, so it just connects, runs the query, and disconnects. So the only way we had is by using the text file collector, which is, it has much more power because it lets us do very complex stuff in our favorite scripting language, and then just simply write a file, as I'm doing here with the echo, write a file that has the metric we want, the labels, and then the value, okay? And in this case, as I was mentioning, PMM doesn't know this is going to be run against our Postgres instance, because we can use text file collector for gathering data from Postgres, from Mongo, from MySQL, from the OS, from wherever. So it won't append metadata on the service name. So this is something that we have to manually add, and this is one of the complexities that it has. So if you don't use the same service name that you have added the client with, you won't be able to match the metric name afterwards in your dashboards, right? So this is, I guess, the most important caveat if you are going to use the text file collector. So what are we doing here? Very basic. We are getting the wall LSN when the script starts, and then we are just looping with a while true there, so forever, and we are sleeping every 5 minutes and getting the new LSN position of the wall. So what can we know with that? We can know how much the LSN advanced. So basically, how much data was written to the server, right? And if we have these metrics historically, we can say, okay, in the last 30 minutes, there were 10 gigs written, right? So then we can say, if our checkpoint timeout is 30 minutes, if our wall files are a bit larger than that, we are probably okay, and we won't have to force the checkpoint just due to the low wall size, right? So how does this example look like afterwards? Looks like this. And this is actually very cool. I'm very proud of this. So what we have is, on the left, we have the checkpoint stats, which means that PostgreSQL is doing and you can see here, this is 5 minutes. So this is a lot, constant checkpointing. And we have the checkpoint timeout here in blue at the right, so it's 5 minutes, right? So our checkpoint timeout is 5 minutes, and I would expect to only have checkpoints every 5 minutes. If we have more checkpoints, it means that our wall size, our max wall size, is too low. And in here we can see that the max wall size is set at 1 gig, and then every 5 minutes, these are these bars, every 5 minutes we are writing up to 14 gigabytes, right? So this max wall size was severely small for these workloads. But now the cool thing is that we have an exact value that we can use to set the max wall size and not have to double guess and increase until it stops doing checkpointing, right? So we have a very good approximation of the max wall size we can use. Of course, when you increase the max wall size, you will have more I/O available because it's not doing so much checkpoints, which means that you can do more writes. So it could happen that when you increase the max wall size, you have to increase it again because you just increase the performance of the server. But again, this is a very good initial approximation to what a good value could be. And then this is the advanced data exploration dashboard that we can use to get all the metrics that we have in Victoria Metrics, right? So this is actually very useful for debugging and testing, right? So when we add a custom collector, the first thing I do is go to this dashboard and write the metric name here and check if we have data, right? And this dashboard will get you the gauge as if it were a gauge and if it were a counter, right? So as we can see here, this is a value that then we have graphed in here, right? So another example, this is what we are actually using. We have in support, we have a shared server that we use to deploy instances for working on tickets. So this is a dashboard I created so that we can keep tabs on how many instances we have running, and then we can go and chase, in this case, whoever is having these 20 AnyDB instances running, we could go and check, are you really using them? If not, turn it off, whatever. So what I used here was a text file, again, a text file collector with a very simple bash script that just checks the amount of AnyDB instances running, MySQL instances, Postgres, whatever, okay? And then we have also disk space usage in the home directory and another mount point that we use. As you can see, heavily used, it's like 3 terabytes. So yeah, you could do all of these things very easily with a custom collector, knowing that, again, PMM won't handle any labels for you. So very powerful. If you this actually has to have a PMM client. The PMM client is the one that will run the collectors. Both. Yes. So let's say if you have 2 different PMM clients monitoring 2 different databases, yes, you will have to do this in both. Very good question, actually. How much time do we have? Okay. So the third supported way is to use external exporters. This is very enticing to use because this means that we have all the job done for us. The only thing we need to do is to figure out which exporter can do what we want. So it's up to the exporter itself to collect the data and expose it to a port. And we already have examples of exporters by, again, the MySQL metrics exporter, the Postgres, and the Mongo exporters, right? So it's the same principle as that, just that it's an exporter that we don't include natively in PMM. So then, again, PMM client connects to this port, and what it does, it acts like basically a proxy between that exporter and PMM server, and just forwards the metrics. And then in this link, you have some exporters that are already working, known to work with Prometheus, which again, we use Victoria Metrics, but it's like a drop-in replacement. And then the online documentation on how to use this, okay? This is for the external exporters, and this is for getting the exporter. So there are 2 ways in which we can use this. The external will get the metrics from an exporter that is running in the client itself. And then the external serverless can do it from an exporter that is running on another host, right? And then you can use the help commands to check the syntax and the available arguments. So this is the external one. In this case, the PMM client is running on the node itself, and then you have the external exporter. And then in this case, PMM client is running on another server, and then it will remotely connect to this external exporter and get the metrics from it. So what did we do with the external exporters? Actually, yesterday we had a tutorial with Marcus on how to troubleshoot performance and issues with PMM. And we used the eBPF exporter to get data on block I/O, latency, and size. So what we did was, in the same node as we had the PMM client, we ran the eBPF exporter, which with a configurations file to get the block I/O trace points from BPF. And at this point, this exporter is running, and I didn't do anything to configure it or anything else, right? So this is like a basic example from the documentation even. And now we have the exporter running and publishing the metrics to our port 9435. So what we can do next is to tell PMM, okay, PMM, I have a new exporter, which is exposing the metrics on port 9435, and I want it to be named eBPF exporter BIO trace points. And at this point, we already have the metrics working. So we did nothing, and this is all for free. And the next step, of course, is to make sure we have a dashboard or to build one, which in this case would be the most difficult part. So in this case, we were lucky because this was done by a colleague of us some years ago, Sergey. He did this dashboard already. So we have it available. If you go to this blog, you will have the dashboard definition. It needs some tuning because some things are a bit outdated, but I will probably put the JSON file I use for the new dashboard in my GitHub, which is going to be the same as this one. Okay, so if you check this repo from my GitHub, I will publish it there if you want to check it. Okay, and the dashboard we have, and actually I have it running here, which is way more cool than a screenshot. So let me show it to you. So in here I added it to a start. You can click on the star here, and it will add it to this menu. So if you use it a lot, it's nice to have it there. So what we do is we select the device. In this case, oh, let me go back because the server is not running anymore. And I will need to refresh. So this is a very good point. If you don't have metrics, the templated variables won't be correctly filled, right? So if you are expecting to see something and you're not, check if you are getting metrics, because in this case, as you can see, we only had the devices that were not really having data. So, okay, let's do this. Let's zoom here. And what we get here is block I/O. This is a heat map. If you're not familiar with it, what we have on the vertical axis, these are buckets, let's say, and in this case, since it's for latency, we have like buckets of from 1 microsecond up to infinity, but let's say 1 minute. So these are going to be reads that are grouped into these buckets. So if it's, let's say here, this red one, right? You can see a bucket there is between 8 and 16 milliseconds, right? So it could have taken anything between those two ranges, right? And then we have on the horizontal axis we have the time, and then on the 3D axis, let's say, which is the color that each square is using, this would be like the Z, and that is the actual the amount of reads that had that latency. Okay, so this is a very nice way to check data that you have that is using more than one dimension, let's say. And then in here we can see, okay, at this point it was heavily doing this, I guess. Where is the, oops. Here. Well, there you go. So this was mainly doing, what does it say, between 500 microseconds and 1 millisecond writes. Okay, most of them are grouped there. And then the worst we have is like 30 something or 65 milliseconds. And then in here you have a percentage, etc. So this dashboard you can get most for free because all the work has been done. And at the end we added some bio pattern, which is telling us if the operations were random or sequential, right? So this is very good data to have also. This we did with a text file collector. And then, yeah, this is a high RAM dashboard I was mentioning, in which we have all the instances, all the instance usage. So let me go back to the presentation. Oops. Close this. Close this. Yeah. So that is all for the 3 supported ways of extending PMM. This I just want to show because I think it can really add a lot of value, which is using Loki. Loki is a log aggregation tool, which means that now in PMM we can have also text-based data, right? Not only metrics, let's say, not only numbers, right? Now we can have text-based data, which on the most simple case could be the logs, right? Just the MySQL error log or the Postgres or the Mongo error log. But then we can also have cool things like show process list or show engine InnoDB status. We can have those also uploaded to PMM, which is something we don't have now. Even if we have query analytics, it's not the same as the show process list, right? Or the show engine InnoDB status. So on the client side, the only thing we need to do is to install a client that can upload the logs to Loki. You can use Promptail or any other that is compatible with it. And then of course you need to deploy the Loki server. Okay, I did it. There is a blog post. The first one is doing it in non-Kubernetes PMM. The second one is Kate's PMM. So you have both ways. If you use Kubernetes, just go to the second. And in the first one, I just deployed Loki in the same server as PMM server is running. That's the most simple you can get, right? So after you have Promptail working and the Loki server, you can tell PMM to add this new Loki server. It has like a data source. It's all explained in the blog post. It has a data source. So you add the data source to Loki, and then you can get from the Explore dashboard, you can already get almost instantly. As you can see here, it was the last minute. You can start getting the logs. And what is very nice, I'm not sure if you see it from there, but Grafana will get the lines that have errors, and it will paint them red here, and the lines that have warnings, paint them yellow. So it's even nice in that sense. And yeah, you can use as I said, logs or whatever text output. It will just read the files that you, Promptail at least, will just read the files that you pointed to. No, well, let me check. In 237? Yeah, the release notes don't mention anything, but I will check. I don't know. That's strange because after I created the blog post, I had some discussions with the dev team, and they said that for now they were not going to do it, but I will check again. Would be really nice if that were the case. So yeah, that's all for the external exporters, the custom collectors, the official and unofficial ways of doing it, and oops. In this short troubleshooting section is like, what can you do if you are expecting to get metrics and you don't? Well, the first thing I would go to is on the PMM client itself, check the logs, because that may already expose some of the errors. And then the second way is the one that we already discussed, going to the advanced data exploration dashboard and check if the metric is being exposed there before trying to build a graph or a dashboard. That this would be my first step. A third way would be to check the PMM server logs, although I don't think it will have any information on this because it's all on the client side, but you can check maybe Victoria Metrics, the Victoria Metrics log have something of interest. And then regarding dashboards and graphs, what I always suggest is to duplicate an already existing dashboard and modify it. That's because you get all the, you get for free, let's say, all the templated variables we are using, and you also get like a basic layout that you can base off of that is already something that works well, right? You can easily delete graphs or remove them or move them around if you need, and again, you can even, like I did on the wall, this one, on the wall size dashboard. This I actually based off of from the MySQL graph that was created. So it's just as simple as that. Then Grafana has a dashboards library, which you can use. I would use for copying the JSON for the graphs and the metrics. But I would still duplicate an already existing dashboard for the templated variables. That alone is really, really something good that I haven't seen in other dashboards. And it's super specific for PMM. So, sorry, you can get dashboards from here. And they also have online documentation on best practices for creating dashboards, which you may want to read just so you can create better ones that are more understandable. And then one important note is that PMM, when you upgrade it, it won't save the dashboards, so it will basically override them. So what you need to be very careful, because you can lose very precious work. And what you can do is, let me actually show it here. Let's say I want to save my Hiram usage dashboard. You can go here and export and save to a file that will be a JSON file that you can later import easily with where am I? Oops. This is so hard. So you can where are you? You can then import it, like upload the file there, and it will just recreate it after you upgrade PMM. So unfortunately, it's a very manual process, but for now, this is what we have.
Question.
Yep.
While it's manual, is there some curl or wget magic that you can use to
Yes.
make it less manual?
Yes, that's a very good question. You can go to the Grafana actually on the latest version we are now using Postgres for storing the Grafana configuration. Before it was SQLite, so I haven't done it yet, but in theory you could just PSQL and then -C, select star from dashboards where name is whatever your dashboards named are, or just get all of them and then you figure out what you do. Sorry. Sorry. So it is possible. I'm not sure how importing them would work in that sense, but I don't see why it wouldn't work. So just like select from and then insert after you upgrade, and that should work. Yeah, it did work for SQLite, that's for sure. But I would have to check for Postgres. But yeah, that would be less painful, let's say. And yeah, with that, unless you have any questions, I think we have 10 minutes left. So we don't have questions, or I will give you 10 minutes of your time back. For what? For the custom query? Yeah. No, you. No, the external exporters. Yeah. No, that will depend on the exporter itself. It could be one or it could be a million. So the PMM will connect to that port. You know, like we can do now. I'm not sure if I have anyone I can show you, but you can with curl, you can connect to that port and it will get you the metrics, right? And it's like what we are using now. For instance, our MySQL exporter, it's exporting a lot of metrics, right? So there is no limit to it. The only limit is what you can send over the network every 5 seconds, because if it takes more than 5 seconds, it will time out. That's the only limit. Yeah, but actually, your issue now is that the server cannot access the client. And that was because you were using Prometheus, and Prometheus only has the pull kind of mode. Victoria Metrics, and this is why we are using Victoria Metrics mainly, has the push mode, right? So what Victoria Metrics can do is the client connects to the server and pushes data to the server. So actually, the connection is only outbound. You don't need to open any ports, okay, right? So that would be a great benefit in your case.
Well, that's beautiful, except I can't let my data out of my on-prem secure site. It's been certified by the government.
But it doesn't have to. I mean, the PMM server can run inside there.
Oh, I didn't know that part.
Yeah,
Okay.
yeah. It can run wherever you. No. This can run on premises on your servers. Yeah. And then in particular the replication lag YAML file. I don't have it public, but I can upload it to the Percona live repo I have, and you can get it from there.
Yes, please.
Yeah, it's the repo is this one. Where was it? It's going to be this. The PDF will have the link, but it's going to be this one. Okay, this is my GitHub handle, and this is Percona Live 23. I will add everything here. Yeah. Huh? We already saved that. Yeah. Okay. Any other questions? Thank you very much for your time and for coming. And if you have any other questions, just email me. My email should be here also. No, but it's my first name dot last name at Percona, or just yeah. open a forum question. Thank you very much, guys.